Hi everyone, welcome to the Mathemagic channel. Today we cover this beautiful equation to the power 6. This equation will have solutions in the real numbers, but we're also going to explore the solutions in the complex numbers. So make sure you get your seatbelts on because this is a tricky one. And let's get started. A simple change of variable, u equals x cubed, seems to be in order here, so that we can rewrite our equation, and our new equation looks a lot like u squared minus u minus 2 equals 0. Ask yourself then what factors of negative 2 could be if you wanted to separate negative 2 and factorize your quadratic. You could either have the factor pair negative 2 and 1, or you could have the factor pair 2 and negative 1. Now the first factor pair adds up to negative 1, the second factor pair adds up to positive 1, so we want the first factor pair. And so let's factorize our quadratic here as u minus 2 factor of u plus 1 equals 0. And this is great because when you have a product and it's equal to 0, then either u minus 2 should be equal to 0 or u plus 1 should be equal to 0. Now this first factorization leads you to u equals 2, and the second one leads you to u equals negative 1. Let's remember that u was x cubed, so we'll have x cubed equal 2 or x cubed equal negative 1. And since we're solving in the real numbers to start, we can say that x is equal to the cube root of 2, or x is equal to the cube root of negative 1, which is negative 1. So we don't need to write cube root of negative 1 as it cube roots quite easily. So these are good solutions in the real numbers, so what we call in R. But let's not forget that mathematics includes complex numbers, and so we're going to look also at solutions in what we call C. And C is the complex numbers, and these generate imaginary solutions, which we have here. We have a representation of the Argand diagram on the left. We see that x1 is actually the cube root of 2, so x1 has value approximately 1.26, that's the cube root of 2, and x2 is just negative 1, so these are real number values, and so x2 is negative 1. Now in the complex numbers we're going to have some additional solutions which are going to rotate, since there are 3 of them, because we're looking at solutions for the cube roots of negative 1 and the cube roots of 2. Then these are going to rotate anti-clockwise around the Argand diagram in 2 pi over 3s. And so they'll be generated by what we can say is 2 pi over 3n. So 2 pi over 3n generated from the origin, from the real solutions, and we can just write those out. Now, if you're not comfortable with complex numbers, this section might be a little bit difficult, so perhaps familiarize yourself with how complex numbers work, de Moivre's theorem, and rotations around the origin. I'm just actually going to write the solutions out, so for those of you who haven't done complex numbers before, this will make a lot of sense. For those of you who have, you'll be happy to see a complete solution to this question. So I'll just write my solution set here, and I'm just going to use squiggly brackets and say W1, W2, W3, all the way to, now you don't have to do this, you could just say W1 to W6, but I just want to make sure that we're all on the same page here, W6. So this is going to be equal to the values. So if perhaps we start with W1 to W3 as the original values generated by the cube root of 2, and then we'll do W4 to W6 as the cube root of negative 1. So for the cube root of 2, we can say, well, the first one is just going to be the real value, which is the cube root of 2. We don't need to put this in imaginary form because it's actually a real number. Now for our first imaginary value, we can use exponential notation. So we can say this is going to be the cube root of 2 times e to the 2 pi over 3i. And then we'll have, for our next value, the cube root of 2 times e to the 4 pi over 3i. So these are the values generated by the cube root of 2. And then for the cube roots of negative unity here, we'll have negative 1, which is already there, so we don't need to say anything about that one. And thinking that the modulus is -1, so the length or the distance from the origin is -1, we can just focus on the argument, so the angle from the origin, which is just going to be the same thing, e to the 2 pi over 3i, so moving in 120 degrees, and e to the 4 pi over 3i. So these are the 6 solutions generated by this equation, of which 2 are real. So the 2 real solutions are the cube roots of 2 and -1. And then the imaginary solutions are given to you here by rotating around on the Argand diagram in 120 degrees, or if you're speaking in radians, rotating in 2 pi over 3s. So this is a complete solution because, of course, you could have 2 real solutions and stop, or you could realize that if you're looking at a 6-degree equation, most likely you're going to have 6 solutions. Thank you so much for watching this video with us. I know it's a little bit involved, but this is how you would solve this equation should you consider all the solutions. Make sure you like and subscribe to the Mathemagic channel to support our work and our videos for you. I hope you enjoyed this video, and we shall see you on the next one.